Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Have a nice day. Today we will learn about velocity diagram for part 1. This is determine of velocity diagram or acceleration on mechanism method. There is two kind of velocity or acceleration method to calculate about that. The first method is instant center or instantaneous speed center, and the second is relative speed velocity. Now for the first method, we will discuss about instant center. An instant center can determine an instant is a point on object where the object is either rotated relative to it. That's the first definition. The second definition is a point in one body about which some other body is rotating either permanently or at the instant. For the two of kind definition, we can take some conclusion like a point common to two body having the same linear velocity in both of magnitude and direction in each. Both of part of this definition are important. Soon we will make use of them in locating instant center. Look at the illustration below. You can look there is four link, four link and two and 1, 2, 3, 4 for join. The first link or not move can be noted as 1 like this for O12 and O14, while O12, which is the link between link 1 and link 2, can be said to be a center point of 1, 2. At the center point, the link 2 rotate to object 1. This is also applies to center point O2, 3. And if link 3 is held, so link 2 will rotate relative to link 3 with center of O23 in this area. In this case, the difference between a center point of O12, O14, O23 and O24 is from differences is O12 and O14 is fixed center point. Fixed center point or fixed center, while for O23 and O24 is a moving center point. After we learn about the illustration before, we can determine of instant center. On any object that has motion relative to one point to another will have a center of instantaneous velocity or instant center. The point of the object fulfill the following condition. For the first condition is all point of the object will have same instantaneous center of velocity or instant center. The second determine is the center of instantaneous velocity on a line perpendicular to direction velocity of that point. Of course, the line of drawn from the point we are reviewing. The third determination is the intersection of the perpendicular line of is the object is continuous center of velocity or instant center. For furthermore, we can look illustration. This illustration, yeah. We have two objects move from the first position to the second position with velocity of point A and B. In the first position, for velocity is VA and VB. This is VA, this is VB. Where the velocity of point A and B are in the position the second VA and VB. First of all, we find the instant center at the first position, namely by drawing a line perpendicular to VA and VB. This direction for VA and VB have a line for a perpendicular line like this. The intersection of the perpendicular line, the struck is the instant center of 1, 2 position. This is for instant center for VA and VB. The same thing we do for the second position. After that will be seen the instant center of the two objects change between first picture and second picture is the same position. That's why point O12 is called the instantaneous speed center or instant center. Okay, we can discuss various instant center conditions. There is have two kind of instant center condition. That moving object is considered to be rotating toward a center of motion. In figure A, there is an object sliding toward to center O12 and this center. Meanwhile, in figure B, a slider that moves translation. If A have rotation, if B have translation or linear motion. An object that moves upright is strike can also be rotational move in infinite radius. Same like the picture A. Picture A have a radius for rotation this object. On B condition or slider condition, the same have radius, but the radius is infinite. For determine the instant center, we can use Kinematic theory. Kinematic theory is defined as follows, like this. When the three objects in a field motion relative to another, there will be three instant centers which will in straight line like this. To discuss this theory, consider a three-piece object in one plane. In one plane like this. Based on Kinematic theory, that the point O12, O13, and O23 must be in a straight line. Suppose that point Q at the O23 and point Q2 and Q3 belong to object 2 and 3 like this. Since point Q is the line center point between object 2 and object 3, that the velocity is the same. The velocity Vq2 is equal to V Q3 and equal to V Q23. This velocity is same, but they have a different for speed direction. This is step about to define instance center. We can use this equation. This is the number of instance center. The number of instance center on mechanism can be determined by the following this equation: n equal to n multiply n minus 1 divided 2. Big N is number of instance center, little n is number link on mechanism. To find the center instance center, we can use the Kennedy theory and using the pie chart. Okay, we will discuss about the sample for question like this. This is have four link mechanism. Pie chart method determine two location of instance center. To explain the four mechanism for instance center, we can use following the equation before. So we can use step by step. The first step is find the main center point, namely 1, 2, 3, 1, 1, 2, 0, 1, 2, 0, 1, 4, 0, 2, 3, and 0, 2, 4. This you can namely for join like this: 0, 1, 2, 0, 2, 3, 0, 3, 4, and 0, 1, 4. So the number of center point in this mechanism, we can use the equation like this. The result is for this mechanism have the 6 instance center. This is a first step for to find instance point of instance center for this mechanism. For the second step, you must make some list for instance center. This is for a number of link, and then this list below account about instance center. For link 1 we have a 3 instance center, 1, 2, 3. For link 2 we have a 2 instance center, 1, 2. For link 3 we can only one for instance center. So we can calculate all the instance center is like this. This is a list for instance center. For the definition or about the list, for the red number of instance center, we already know about the position. 0, 1, 2, 0, 1, 3, and 0, 3, 4. And the last is 0, 1, 4 like this. And then the black number, there is not yet know the position, 0, 1, 3, and 0, 2, 4. We can determine about the instance center not yet found for this equation, the remain for the instance center is 6 minus 4, so we know that about 2 of the instance center not yet have the position here. Now we can we must find the 2 for instance center for O13 and O24. We can use for a pie chart method, yeah. Okay, let's find the instance center for point O13 and O24. First, you must draw the circle like this and divide for link 1, 2, 3, 4. We can assign for link 1 like this, and then link 2, and then link 3, and the last link 4. Okay, after that you draw the line for connection for link. This is line for connection instance center for O12. This position for instance center which have already know O12, and then you can draw another line for connection for instance center for O23, this position, and then make a line for O14, 4, this position. And then the last line is for connection between link 3 4 O 3 4, like this position. Now this is a link for instance center, which already know, yeah. 1 2 2 3 3 4 and 1 4. 1 2 2 3 3 4 and 1 4. Now we draw the line for position, instance center position for 3 1 3. Like this. You can see about the line. This line is divided for 2 triangle, 1 4 3, 1 2 3 and 1 3 4. So after that we can draw the line in this mechanism. This line divide 2 triangle, 1 2 3 and 1 3 4. So you can make this line, and you can draw but the link for O 1 2, this area, to O 2 3, O 2 3. You can draw like this. This line for this area 1 2 and 2 3, and then after that you draw the line for point instance center or O 1 4, this area, O 1 4, this area, 3 4, O 3 4. This is like this. For intersection about between two lines, this area, we can call this instance center for O 1 3. This is O 1 3 position. And then after we find the instance center O 1 3, we can try to draw about instance center in O 2 4. You can take a line 2 and 4 like this. You can see the line for 2 4 divide about 2 triangle, 2 1 4 and 2 3 4. That you must draw in the line for line about O23 in this area, O23 to 34. Yeah, like this. You can move but right chat. Like this. Okay. This is a line about a connection between O2323 and O34. And then you must draw the line between O12 and O14. O12 in this area, you can draw like to O14 like this. The intersection between the first line and the second line, this is a instance center for point O24. Okay, now you have found all the instance center for a 6 position here. And this is for O112, O14, O23, O34, and the two last instance center is O13 and O24. For another sample, you can look at the video after this. Check it out.
Hello viewers, in today's class we'll look at a problem on instantaneous center method in a 6-link mechanism. This is the problem. A mechanism as shown in figure has the following dimensions: OA equal to 200 mm, AB 1.5 meter, BC 600 mm, CD equal to 500 mm and BE equal to 400 mm. Locate all the instantaneous centers. If crank OA rotates uniformly at 120 rpm clockwise, find velocity of point B, C and D and angular velocity of links AB, BC and CD. This is the drawing. First, as usual, we will do some initial calculations. Here given the crank speed OA is 120 rpm. So our length of the OA is 200 mm. If we convert that will be equal to 0.2 meter. We know that omega equal to 2 pi n by 60. So omega of OA, that is angular velocity of the link OA, will be equal to, by calculation we get 12.57 rads per second, and velocity at point A will be equal to will be equal to omega into length of the link OA. So that will be calculated as 2.514 meter per second. Now the procedure to construct the instantaneous center drawing. First we have to draw the space drawing. We have to draw the exact dimensional drawing as given in the question. So this will be the exact dimensional drawing as given in the question. Let us name the points of the links O, A, B, E, C and D. Now we have to calculate the number of instantaneous centers. Here obviously we will be having 6 links, so number of instantaneous centers will be equal to 15. Now the third step is we have to name the links and name the instantaneous centers. Let us go with link 1, link 1, link 1. Why? Because all the 3's are link 1, all the 3 elements are fixed points. So this is a fixed point mentioned as the same link. This is another fixed point, this is a cylinder, another fixed point. As per our kinematic rule, all the fixed point must be named with the same link numbers. So all the 3 are link 1, and this is link 2, link 3, link 4, link 5 and slider is link 6. So now these are all the various 15 instantaneous center we need to locate. So I12, I13, I14, I15 and I16, I23, 24, 25, 26, 34, 35, 36, 45, 46 and 56. Next step is we have to locate all the fixed and permanent instantaneous centers available in space drawing. That is nothing but what are all the available instantaneous that we can locate with this available drawing. We have to locate it. So now here this is link 1 and this is link 2. So obviously this point will be instantaneous center between link 1 and 2, that is I12. Similarly this point is between 2 and 3, this is I23. Similarly we can put mark here and we can put tick mark there, so that we can complete the identified instantaneous centers. Now this will be I34, so we can put tick mark over here, and this point represents, this is link 1 and the whole thing is link 4, so this is I14. So we put tick mark here, and this point is between link 5 and 4, so therefore this is I45, and this point is between link 5 and 6, so that is I56. Now the next thing is we have to locate the instantaneous center for a slider. As usual, the slider is assumed to be that it is rotating at infinite center. So there are three fixed centers here. This is one fixed center, slider cylinder is one fixed center, and this is another fixed center, and this is another fixed center. As per the procedure previously taught, all the fixed center must be drawn a straight line where the slider exists. So the slider is assumed to be rotating at infinite center, and here is also another fixed center. We have to draw a line over here. Here is also another fixed center. We have to draw a line over here, and everywhere we have to place that instantaneous center between link 1 and 6, that is represented at infinity. So therefore I16 is at infinity. Here also I16 at infinity, and in this place also I16 at infinity. So we have located these instantaneous center right now. We'll continue the problem. Next step is we have to locate the remaining instantaneous center using hexagon diagram. Why hexagon diagram? Totally we have 6 links over here. To represent 6 sides, we have to represent in hexagon diagram. So there are 6 corners of hexagon. Each corner represents one link. So this first corner is link 1, second link 2, link 3, link 4, link 5, and link 6. Now next thing is, what are all the instantaneous center we have already located, we can mark over here. That means we have located instantaneous center between I1 and 2, so that we can represent a 1 2 here. 1 2 is marked, 2 3 is marked, 3 4 marked, 4 5 marked, 5 6 marked, 1 6 marked. We have marked additionally one more thing, that is 1 4, so that is known to us. So we have drawn a line between 1 and 4 because we have marked I14 also. Now we have to draw one line. Either we have to form any line, either we can start in any way, either 2 4 or 1 3 or any way. Let us start with 2 4. So if I draw a line over here, this represents 2 4. This 2 4 means this line is common between two triangles. That means 2 3 3 4 is one line, 1 2 3 3 4 2 4 forms one triangle, and 1 2 1 4 2 4 forms another triangle. Now we have to extend a line from two instantaneous centers, that is between I23 and 34. Where is I23? Here I23 is there, and here I34 is there. So in this straight line anywhere I24 exists, and we'll go with I12 and 14. This is 12 and this is 14. Where is 12? This is 12 and this point is 14. Obviously these two intersect at one point. This point must be our I24, because I12, I24, I14 forms a straight line. I23, I24, I34 forms a straight line. Both satisfy Kennedy's theorem. So now this point is our I24. We have located I24. Now we'll draw another line over here, that is between 1 and 3. So this is I13. Now this 13 is common between 1 2 2 3 as well as 3 4 1 4. Now we have to go with 1 2 2 3. So this is 1 2 and this is 2 3. We have to extend the line over here, and another is this one is 3 4 and this one is 1 4. We have to locate I34. This is 3 4 and this is 1 4. If we extend a line over here, if we extend both the lines, the intersection point will be I13. Obviously we have drawn a line from 1 2 to 2 3 and extended. We have drawn a line from 3 4 to 1 4 and extended. Both will have intersection at one point. That intersection point is I13. So now this is located. So this is I13. We have to go with remaining instantaneous centers. Now we'll go with the next instantaneous centers. So we have located up to I13. Now secondly, we have to go with the next instantaneous center. We have to continue the hexagon diagram further. So how to continue? We may go with either 1 5 or 4 6. Let us go with 1 5. if I draw a line between 1 and 5, that will be 1 5. So 1 5 is common for 1 4 4 5 as well as 1 6 5 6. We have to check where is 1 6 and 5 6. 1 6 is at this line at infinity and 5 6 in this point. If I extend a line here, somewhere in this line I 1 5 exists. Let us extend it. Now we'll go with the 4 5 and 5 6. Where is 4 5? 4 5 is here and 5 6. Sorry, we have to draw line for I 1 5. 1 5 is common for 1 4 4 5 as well as 1 6 and 5 6. So now we have to go for 1 4 and 4 5. Where is 1 4? 1 4 is here and 4 5 is here. So in the same straight line I 1 5 exists. So if I extend the line over here, it intersects at this point. So this point will be obviously I 1 5. We can mark that as I 1 5. We have located I 1 5 and we can put tick mark over here. Next thing is we have to locate between 4 and 6, that is I 4 6. Now 4 6 is common for, we can check 4 6 is common for 1 6 1 4 as well as 4 5 4 6. Where is 1 6? 1 6 is at infinity, 1 4 is in this place. So in between anywhere or in this line we have to have I 4 6. And one more thing is 4 5 5 6. So here 4 5 5 6. 4 5 is here, 5 6 here. Obviously this intersection point will be giving us I 4 6. So this is I 4 6. We have located I 4 6. We can continue to locate remaining instantaneous centers. Let us go with the 2 5. So if I join a line between 2 and 6, then that is 2 6. We'll find initially 2 6 and then we'll go with 2 5. So 2 6 is nothing but if I draw a line from 1 2 to, if I extend a line from 1 2 to 1 6 and extend a line from 2 4 to 4 6, the intersecting point will be giving us 2 6. 1 2 and 1 6 is representing in the same straight line. So and 2 4 and 4 6 are there. 2 4 is here and 4 6 here. If I draw a line and extend here up to here and extend another line here, we can locate I 2 6 like this. We have extended a line, so I 1 2 1 6 and this 2 6 going to form in the same straight line, and we have drawn a line from 4 6 passing through 2 4, and this will get intersection point over here. So this will be giving our intersection point will be giving our I 2 6. Next thing we will find out I 2 5. If I draw a line over here, this forms I 2 5. So now this 2 5 is common between 2 4 4 5 as well as 1 2 1 5. So if I extend a line from 1 2 and 1 5, and if I extend a line from 4 5 and 2 4, I can extend a line from 4 5 and 2 4, I can extend a line from 1 2 and 1 5. The intersecting point will be giving us I 2 5. I extended a line from 4 5 to 2 4 and stop with this, and I extend a line from 1 2 to 1 5. The intersection point will be giving us I 2 5. So we have located I 2 5. Remaining two instantaneous center we may not able to look, we can locate it, but it will go out of the paper or out of the screen. So with this available data we can do calculations. So it is enough for us to locate up to this instantaneous center. Also it is tedious to complete all the locate all the instantaneous center in given time, because it will be little bit time consuming process, and we can stop up to this. It's not necessary to find remaining two instantaneous center 3 5 and 3 6. It's very easy to locate in the similar fashion, but it will be going out of the screen. So our requirement is we need to calculate velocities for B, C and D, as well as angular velocity of A, B, BC and CD. With this available instantaneous center we will be able to calculate this one. So now we'll go with the calculations. First we have to calculate velocity at point B, C and D. We know velocity of point A. So VA by I13A, this one VA by I13A will be equal to VB by I13B. So by measuring I13A and I13B we can calculate VB. So now to find VC, VC by I14B, VB by I14B will be equal to VC by I14C. Here I14 will be considered as a center of rotation for the whole link. So here point VB is there. VB by I14B must be equal to VC by I14C. So using that we can calculate instantaneous velocity for point C. So now the third thing is to find velocity of point D or slider velocity. So now using this one we can calculate VC by I15C. I15C is nothing but this length. So this is forms a triangle. So VC by I15C must be equal to VD by I15D. Using this relation, we can calculate velocity of point D. To determine angular velocities of the link, AB is here. So either we have to use VA or we can use VB. So let us go with VA. So omega AB is nothing but VA by I13A or VB by I13B. We can use any one, is enough. So to determine angular velocity of BC, VB by I14B, either VB by I14B or VC by I14C, either way we can use this. So now this is any one is enough. To find angular velocity of CD, VC by I1, either VC by I15C or VD by I15D, either way we can do. So by this way we can calculate angular velocities of the links AB, BC and CD. So this by this way we can calculate angular velocities.
Okay, that's all for our lesson today. Now you will try for exam today. Find the number of instance center point and their location from mechanism below. You can draw on millimeter paper. After that, scan and upload in learning. Yeah. If any question, don't hesitate to ask me. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Have a nice day.